All right, so we're starting off just as we ended in the last video. All right, now I'm going to rub off everything here and start resuming the red. So we go in, right? Just to recap, we're starting from the premise. We're starting from the premise that big D, which is a divisor of x, over small d, big D is the dividend, small d is the divisor, is equal to your quotient, comma, plus the remainder. All right? Remember that the dividend, the divisor, and the quotient are all are all functions of x. The remainder will be a constant. All right? We have to get that clear. The remainder itself will be a constant, and that is essential going forward. So, we're rubbing off the rest here now. That being the case, following on from that, we know then that if we cross multiply, we then get that big D of x is equal to Q of x dot small d of x, comma, plus the remainder, r. So we established that as well. Now, at this point is where we get into the fundamental basis of what we refer to as the remainder theorem. All right? So brace yourself, pay attention to this. This is the point where most teaching would start. This is the point where most textbooks would start. This is the point where you will start, generally speaking, in your school, in your class, wherever, online or whatever it is. Right? They will start by just telling you what the remainder theorem is. What I have done in the video prior to this is lay a foundation so that the hope being that your understanding will be enhanced going forward. Yeah? All right. Now, when we say that something is a function of x, it means that the value of that thing is dependent on the value of x. So in other words, d of x, the value of d of x, whatever the expression d of x is, depends on what the value of x is. The value of q of x, the expression q of x, depends on what the value of x is. And the value of small dx depends on the value of x. R is a constant. R is a constant by itself, meaning that it is independent of x. So in other words, the value of r is just the value of r. The value of r doesn't change or fluctuate depending on what the value of x is. All right? That, however, is not the case for big D of x, q of x, and small d of x. So we have a situation here where between these three functions, depending on the value of x in any one of these things, well, in fact, I shouldn't say that. Depending on the value of x period, because whatever the value of x is here, it will be the same value here, and it will be the same value here. That is just the nature of this relationship. So in other words, the value of x will have a profound effect on what happens between these three variables. All right? The value of x determines directly the nature of the interaction between the three variables. It determines what happens. So, to use the simplest, I shouldn't use the word simple, but to use a straightforward example. If x is equal to 0, then it means that everything here will be equal to 0. All right? Sorry, no. Hold on. I made a mistake there. X being equal to 0 is not the same thing as saying that d of x is equal to 0. Illustration. You see, sometimes while you're talking, you have to correct yourself. If I say that f of x is equal to 3x minus 2, right? If x is equal to 0, then f of 0 is equal to 3 by 0 minus 2, which is equal to 0 minus 2, which is equal to minus 2. All right? So saying that x is equal to 0 is not the same thing as saying that f of x is equal to 0. On the contrary, I'll leave that right there. If f of x is equal to 0, then it means that 3x minus 2 is equal to 0, which is to say then that 3x is equal to 2, which is to say that x is equal to 2 over 3. So in other words, the value of x that makes f of x equal to 0 is x equal to 2/3. Right? The value of x for which the function f of x is equal to 0 is x equal to 2/3. In other words, in the language of mathematics, we say that x equal to 2/3 is the root of the equation 3x minus 2 equals 0. In other words, x equal to 2/3 is the root of f of x. Anytime we refer to something being the root of an equation, being the root of an expression, being the root of a function, the very phrase the root of implies that you make the function equal to 0, that you make the expression equal to 0. So if f of x is equal to 3x squared minus 2x plus 4, and we want to find the root of f of x, you equate 3x squared minus 2x plus 4 equals 0, and you find the solutions to that equation. The solutions to that equation are the roots of f of x. Notice that I said solutions and not solution, because the example that I just quoted was a quadratic example, which means that you will have two solutions and not one. Remember that from some of the previous videos on polynomials. All right? So, this idea is important here, because let us consider some value of x. Right? Remember the origin of this. All right? I can rub off here now. This relationship in orange here is derived from the original relationship where we would have said that, oh, look at right here, man. Big dx over small dx is equal to qx plus r. All right? Now, if we have a particular value of x that makes small d of x equal to 0, right? In other words, we look for the root of dx, the divisor dx. So in other words, we consider some value of x, consider the value or values of x for which small d of x is equal to 0. That is the roots of small d of x. All right? We consider that. So in other words, and we can let that value, let the general value, now it could be more than one value, but for the sake of simplicity, we say let the root of dx equal r. All right? So in other words, what we're saying is that for x equal r, all right? And that could be, now remember that this could be more than one value, right? So what we could do, we could say x equal r I. All right? Now, let me leave that. Let me leave it just as that, right? We explain it for one root, and we understand that the explanation applies to 2 roots. And what we will do, we will demonstrate the difference between 1 root and 2 roots with actual equations. Yeah? So, let the root of d of x equal r. What that means is that for x equal r, small d of x is equal to 0. Now, if we apply that over here, what will we end up with? We will end up with this. We'll end up with we will say that d of r, remember r is the root of d of x, is equal to q of r by d of r plus big R, which is a remainder. So we can see that Sesame Street is brought to you by the letter R, right? R for root, R for remainder. So the letter R features prominently in this session here. Yeah? So this R is one specific value of the general x. That R being a value that makes d of x is equal to 0. And since d of r, so in other words, so we can say now, since d of r is equal to 0, that coming directly from here, right? If x equal r makes d of x equal 0, it means then that d of r is equal to 0. What it means then is that d of r is equal to, if this is 0, then this multiplied by this will also be 0, right? We put it here just for emphasis, q of r by 0 plus big R, which means then that big dr is equal to a remainder r. All right? And this here in blue is what we refer to as the remainder theorem. So in other words, you find the roots of the dividend, the divisor, right? And what you do is substitute that into the dividend. And whatever you get, that is your remainder. All right? So we have everything on the board here. You watching it on the video at home or wherever you're watching it, you have the option to pause and rewind. At some point in the not too distant future, I will type this up into a nice note, right? And of course, I'll come back here in the video to refer to it, to make the note. But in the meantime, you have it here and you could proceed. So, hold on, I have to keep these colors in a place where I could see them. All right? So, what we're going to do? Now we're going to demonstrate this using some actual functions. All right? So again, I can actually stop the video here. I'm trying to chop up the video, it's kind of small. All right? So that you could take your time, watch a piece, and then watch the next piece again, as opposed to just taping right through. All right? So we stop here, and we will resume in the next video, where we will actually do some concrete examples of what we have here.